All right, I'm going to go over problem 11 on the 2016 Algebra 2 exam. As I looked at this problem, just like most of the other problems, you need to know other information that maybe you would not learn in your class, maybe that you learned years ago. So let's look at the problem. In a circle with a diameter of 24 centimeters, a central angle of 4 pi over 3 radians intercepts an arc. The length of the arc in centimeters is. All right, so let's draw a circle here. Let me actually draw a real circle. Maybe that'll help. I'm going to draw a circle. All right, so let's just make a center point here. So in this circle, it says the diameter is 24. So remember, diameter is talking about the entire length of a line that goes through the center point. Remember, it has to go through the center point to be a diameter. That's 24 centimeters. Now they bring up something else with a central angle. A central angle means that the angle would be coming out of the center point. So our initial side would be here. Now, 4 pi over 3, if you've been doing the unit circle in my class, 4 pi over 3 should be pretty apparent what that is. If you're not sure what that is, then you need to do a little bit more studying. But 4 pi over 3, one way you can think about it is pi in degree terms is always equal to 180. So you can really do 4 times 180 divided by 3 if you want degrees. One reason I'm doing this is because a lot of students, they like degrees more. So this would be 720 over 3, which would be 240 degrees, right? You also remember when you go from radians to degrees, you want to multiply by pi over 180. I'm sorry, 180 over pi. Be careful. So, and your pi is going to end up canceling out, just 4 times 180 over 3. A lot of ways to look at that, but either way, we know we're going 240 degrees, which means you should remember that this is 180. So I'm going to have an angle somewhere over here. It's going to be in my third quadrant, and it's going to be like this. So what they're asking about now is the length, excuse me, of the arc in centimeters. Well, what you need to figure out is this entire circle. To find out the length of that, you'd have to find the circumference. Remember, circumference is pi d, or pi times d, or c is equal to 2 pi r. We'll use pi times d because we have the diameter. And that's going to be c is equal to 24 pi. So your circumference is really 24 pi. And if you put that in the calculator as pi, it'd be like, I don't know, 70, it doesn't really matter what it is, but keep it in terms of pi. And you notice all of our answers are in terms of pi. So keep the diameter in terms of pi. I'm sorry, not the diameter, the circumference in terms of pi. So that's our circumference. We want to know how long, when it says that the central angle of 4 pi over 3 intercepts an arc, what they mean is if your angle, the terminal side would be down here. The intercepting part would be all of this. So what they want to, actually I'm going to draw it in green and make it a little different color. What they want to know is what's the length of this arc. They want to know what the length of this arc is. All right, so there might be some type of formula that you want to memorize or anything. I mean, when I sit down to do something like this, my thought process would go something like this. If this angle was 360 degrees or 2 pi, then that would just mean that the arc was the entire diameter. I'm sorry, not the diameter, the entire circumference. But it cuts 240 degrees, so that should be more than half. because it's past 180. So think of it that way. So if it were 180, then it would cut an arc that was 12 pi, or half of our 24 pi. But it should be more than that. So right now, we should eliminate 1 and 2 right off the bat. And really, you could eliminate number 4 because really, there's no way that the arc can be longer than the actual circumference, which 4 is. But I like to think of it this way. I know it's 240 degrees over 360, which means if I cancel out these zeros and I do some other, 12 goes into 24 twice, 36 3 times. So really that angle takes up 2/3 of the circle. So that means it's going to take up 2/3 of the circumference. And 2/3 of our circumference, which our circumference was this. So we can do 24 times 2/3, which is equal to 48 over 3, which is equal to 16, and add on that pi, 16 pi. So that is our answer for number 11. Let's jump to number 12. And think about it for a second. I'll be back. Okay. Looking at number 12. You have an absolute value equation, inequality. And the first thing you want to do is get everything away from the absolute value. So the first thing you're always going to want to do, actually I'm going to show you what you don't want to do, what I see students do. They divide by 4 first, which you don't want to do. You want to add 5 first. Also, some students, they know that you need to split it up into 2 different inequalities, but they'll do it right here. So they'll write 4 times 2x plus 6 minus 5, and then they'll do that, and then they'll write another equation, 4 times 2x plus 6 minus 5 is greater than negative 27. They're right in the fact that they need to do 2 inequalities, but you don't do that until the absolute value is all by itself. I can't stress that enough. You don't want to do that till both inequalities are all by itself. It won't matter for your first one, obviously, but for your second one, you'll get a much different answer. So let's go ahead and do that. And so here we go. So first thing, plus 5, both sides. We end up with 4 times 2x plus 6 is less than 32. Now we divide by 4. Divide by the 4, we have 2x plus 6 is less than 8. Now we want to set up our 2 inequalities. So we're going to have 2x plus 6 is less than 8, same one. And we're also going to have 2x plus 6 is switch the inequality, and make the other side negative. There are a lot of ways we talked about doing this, but that's a quick, simple way to do it. Now we just solve both of them, minus 6, we have 2x is less than 2, divide by 2, you get x is less than 1. And on this side, minus 6, so we end up with 2x is greater than negative 14, divide by 2, and x is greater than negative 7. Now, some students will look at this and they think about for this second one over here, that right here, that you might need to switch this inequality, but you're not dividing by a negative number. So you don't need to do that. Only when you divide or multiply by a negative number do you need to switch the inequality. All right, so we have and. This is an and. And if you look at the equation we got, forgot to put back those absolute value signs. You don't take it out of the absolute value until after you make your 2 inequalities. Then you can take it out. So if you look here, a nice tip that I heard in class that I had never heard before is when it's less than, and that means and. If it's great or, that means or. Or always means your number line is going to be like this. And means it's going to be like this. So we're less than and. So we should be having something like this, which in this case is going to be this. And that's why they give you number 1 to throw you off. Also, I'll do it in the calculator and we'll check that out. All right, so our answer is number 2. Let's see, I'm going to show you how to, again, like I said, do it in the calculator. So I'm going to write something down here. I'm going to go to the calculator so we can put it in. And okay, so if you want the calculator, you go to y equals. We all know how to get to y equals. You could plug in the original inequality like this. So you have 4. Let's see, that. So do 4, hopefully you know how to do absolute value. Actually, I'll just go to the large screen. Hit math, then we'll go to here, hit enter, then we'll put in 2x plus 6 minus 5. This is the part some students might forget. You want to test it. So if you see under this green alpha button, there's in blue it says test. I'm in second math. I'm going to go down. We have less than. And here, hit enter. Then we'll put 27. Now the graph is going to actually, when I hit graph, it's going to show me a number line. So it's testing out what values make that true. And as you can see, it's from -7 all the way up to 1. Those are the values that make it true. All right, and that is our answer. Now, if you, let's just say you put in greater than instead of less than. So I go back to second test, and I go here, and I put in greater than instead. Now we're going to see how it changes our graph. You notice what it does to our graph? So be careful if you use this method. Okay, for this problem, a couple things I want to write down. Is the sum of the roots of the equation, -3x squared plus 6x minus 2 equals 0. Make sure, one tricky thing, not on this problem, but it could happen, if you want to find the roots, make sure it's set equal to 0, which this already is. So we don't have to worry about that. But the sum of the roots, you can find by doing -b over a. And the product of roots is going to be c over a. So if we look, remember, this is going to be a, b, c. So we want the sum. So that's just going to be -6 over 3. I'm sorry, -3. So that's going to be a +2 for our sum of our roots. All right, I'm going to go through. Hold on. Okay, now I'm going to go through another way you can do this problem. Now, if you forget how to do the, if you forget the formula for the sum of the roots or for the product, you could just solve this, find the roots, and then add them together. Now, for this particular one, it actually is a pretty labor-intensive process, but it's worth it if you want to get this question right or something similar to it, and if you forget the formula for the sum or the product. So what you can do is just solve it. Now, before I solve it, I'm going to look at the discriminant. And the discriminant is b squared minus 4ac. So that's going to be 36 minus 4 times -3 times -2. So it's actually 36 minus 24, which actually gives you 12. That is your discriminant. What that tells me is the fact it's not a perfect square means that this will not factor. It also tells me that my solutions are going to be irrational. And I'm going to have to use another method. So I'm going to use the quadratic formula. And that's going to look like this. X equals -b. So -b, if b is 6, -b would be -6 plus or minus. We already know what's under the square root because that is your discriminant. So that's just going to be 12 all over 2a, which is That's negative 6. All right, what you do not want to do at this point is do this. That is a no-no. Don't do that because negative 6 is, in essence, married up here to this radical 12. So you can't just simplify or cancel the way that I just did. But you can go ahead and break this down. So x equals negative 6 plus or minus. Now this 12 can break down into 4 and 3. The reason why I picked 4 is because that's the biggest perfect square that's a factor of 12. Again, I'm not changing the value of it, just changing how it looks. So this would be equal to 2 radical 3 because the 4 can come out. All right, so we have negative 6 plus or minus 2 radical 3 all over negative 6. Now at this point, if you have a triangle of numbers here, and all are divisible by something, you can cancel. So all of them are divisible by 2. You can have x equals negative 3 plus or minus radical 3 all over negative 2. So you're going to have two solutions. You're going to have x equals negative 3 plus radical 3 over negative 2, and x equals negative 3 minus radical 3 all over 2. Now, these are my two roots. So if I want to find the sum, well, I can just add them up. So I'm going to have negative 3 plus radical 3 all over negative 2 plus negative 3 plus radical 3. I'm sorry, minus radical 3 all over negative 2. So what you're going to have then is, now you have the same denominator, so you can just add your numerators up on top of one common denominator. So we're going to have negative 3 plus a negative 3, which is negative 6. Although, I think I made a mistake somewhere here, so let's go back and find it. Okay, now I see the mistake. Well, hopefully you guys caught the mistake somewhere, but I realized something when I got to this point. So let's go back and fix that. And my mistake came, excuse me. My mistake came at the point here. When I said 2 goes into all these, 2 does go into negative 6, but it goes in 3. So this should be a negative 3. This should be a negative 3. So I should have, and this should be a negative 3. So when I add these together, these both should be negative 3s. And when I, one denominator, I'm going to have negative 3 on the bottom, and I'm going to have negative 3 plus radical 3, and then really this is going to be, that's going to be minus 3 minus radical 3. So when you combine that, your negative 3's give you negative 6. Now your plus radical 3 and your minus radical 3 are going to cancel out. So you have negative 6 over negative 3, which equals 2. And that's the same answer that we got. I know that's pretty labor intensive, but it's another way to do it. Okay, looking at number 14, I'm not going to spend too long on this, but I do want you to write down this definition of standard deviation. And I'll read the problem. The scores of 1,000 students on a standardized test were normally distributed with a mean of 50 and a standard deviation of 5. What is the expected number of students who had scores greater than 60? Well, if you're looking at mean, for one thing, this means average. Standard deviation of 5. Standard deviation is basically a measure of how spread out numbers are. And it's something we're going to look at, hopefully have time to look at more in depth later in the year, if we have time. I'm just going to go ahead and show you an answer. Someone did an answer key action. I want I want to look at it and then I want to talk about how they got this answer. So the answer is number 2. So the fact you have 1,000 students and you have a standard deviation of 5, and how many had scores greater than 60? Well, in order to do this problem, you have to look in the back of your test when you took the test, or whenever you take one of those Algebra 2 tests, you have this. It's a normal curve standard deviation chart. And that's why they tell you up here that the tests were normally distributed. So you can go ahead and use this chart. And let me cross that out and then underline it. All right, so looking at this chart. When you look at this chart, basically, if you add up all of these numbers, all these numbers here, it's gonna, these numbers, the percentages, not the numbers at the bottom, the percentages, they'll add up to 100. So in reality, the 0 represents your average. And this chart says that if you look at these numbers here, so if you look here, from here to 1, that'd be 1 standard deviation to the right, and this would be 1 to the left. And if you add up all these numbers, that's saying that 15%, and this 15 over here, 30, and then 19.1, I believe that's 38.2. So, what's that? I'm doing some quick math in my head. 38.2% plus 30%. So 68.2% of the scores will fall from, now, if it's 1 standard deviation, and we said in the problem, or the problem said standard deviation was 5, and the mean was 50. That means that our scores in here will be from 45 to 55. That means 68.2% will be from 45 to 55. Now, when you move to 2 standard deviations, we're going to move over here. Now, at this point, I'm going to stop looking at the ones that are negative, because that would mean scores lower. We're being asked about how many had scores greater than 60. So if we look on this side, if you look on this side, this is dealing with 50% of the scores. So 50%. So if you look there, that means that if you go right in, let me erase this now. If you look in at 2 standard deviations, because that would be, if 1 standard deviation is 5, that means 2 would be 10. And it's asking for scores greater than 60. So that's why they have this greater than 2. That's why the guy, whoever did this scoring, put that. Because whoever got a 60 was more than 2 standard deviations to the right. And then if you see this 50 minus 47.7, those are percentages. Now, where that came from is, if you add this score, not this score, this percentage, this percentage, this percentage, and this percentage, you're actually going to end up with 47.7. Let me get a calculator here, just make sure. So I do 19.1 plus 15 plus 9.2 plus 4.4 is equal to 47.7. That means that whoever got a 60, according to all this data, had to have fallen in that area. And that is 2.3%. So looking up here, that's 2.3% of the people who took it, and 1,000 people took it. 2.3% times 1,000, that'd be 0.023. Be careful. Times 1,000 is equal to your 23. There you go. Okay, looking at number 15. If we break this down, and we have log of t is equal to, let's break down the top. So on top we have 10x squared, so that'd be, remember you can break it apart, you can condense or you can expand. I can expand log base 10. Remember, if you have no base, the base is 10, so it's log base 10 of 10 plus log base 10 of x squared, all of that, and then since you have division, that's going to equal your minus, it's the same thing as subtracting log base 10 of y. Now, if you look in here, you can actually move this down, but one thing that might be hidden that you might miss, log base 10 of 10, remember, you can draw the 10 or write the 10 here if you want. Remember, it's 10 to the what gives me 10? Well, that just is 1, so that's going to be 1 plus 2 log base 10 of x, and then minus log base 10 of y. And if you look, that actually is your answer number 1, because there is nothing else you can do with them. All right? So that is it for that question and that set of 5 questions.